हेलो स्टूडेंट्स, अभी ये प्रॉब्लम बहुत ही अच्छा प्रॉब्लम है. इन दिस पर्टिकुलर प्रॉब्लम यू कैन सी that electric field which is provided to us, and that electric field E which is provided to us, just a minute, just electric field which is provided to us, that is E, and that electric field is x plus y I. Okay, then minus 2x square j plus 2y k. So this is the electric field which is provided to us, and we are asked to calculate the electric flux passing through this yellow region. That yellow region is nothing but the region bound between z is equal to 1 and z is equal to 3, also x is equal to 1 and x is equal to 3. So this is the region bound between x is equal to 1 3 and z is equal to 1 3. So you can get this particular square region, and that I have shown with the yellow color here, and I want to find the flux passing through this particular region. Right now I just want to find the flux passing through the region lies in a xy plane. Okay, so I can just say for a region lies into xz plane, not xy but xz plane, I can just consider y is equal to 0, and that's why this electric field comes out to be xi minus 2x square and j. Okay, so this is what electric field we have. Now we have to consider this electric field, and this electric field is basically passing through this yellow region which is bounded by x is equal to 1 3 and z is equal to 1 3. Now what is the formula of flux? Let us write down the formula of the flux. The flux passing through given region, so that flux is going to be integration, okay, E dot dA. This is the integration. Then this integration is going to give you the flux. Now you have electric field, and see what I'm doing here is that I'm just assuming a little element of area dA, that you can see here, that small element dA, that is basically pointing along y axis, and that small element dA is a basically square in shape whose one side is dx and another side is dz. So dA can be written as dx into dz, and as it is pointing in y direction, I'm just choosing j cap here, right? So I'm just substituting the values here. So electric field is basically xi minus twice x square j, and area vector is basically dx and dz j. So whenever there are two variable comes, no, dx and dz, so we have to go with the two integrations. Okay, whenever we have two variables are there, we have to go with the two integrations. So what this two integration is going to give us, let us see that. Okay, so one integration is for the limit of x, and that is 1 2 3, and one integration is for the limit against z, that is also 1 2 3. Okay, so two limits are there, one limit is for x, another limit is for z. So now let us take the product, and when we take the product, I can see that I dot, this is dot, so I dot j is going to be 0, so only j dot j term will survive, and that's why this is going to be 1 2 3 1 2 3, and the surviving term is going to be minus 2x square dx and dz. So in this particular case, I'll separate the integration. This is the x limit 1 2 3, so it is minus 2x square dx, and this is y limit 1 2 3, and that is dz. Y limit 1 2 3, and that is dz. So now what to do? So let us integrate this. So minus 2 is outside, this is going to be x cube upon 3 1 2 3, and here dz integration will be z, and that is also 1 2 3. So it is going to be minus 2 by 3, and this basically 3 cube is 27, and 1 cube is 1, so 27 minus 1 is 26, and here it is 3 minus 1, it is 2. So just make a multiplication of this. So what will be the answer? And if you multiply this, you get this answer 34.7 Newton into meter square upon Coulomb. So option D would be the right answer, right? So this is what the calculation of electric flux passing through this yellow shaded region. I hope you have understood this. Thank you very much.